Okay, so we're looking again at derivatives, which is the instantaneous rate of change at a particular value on a function. And then we were talking about the existence of a derivative. So the existence of a derivative, it has to be continuous at that value. The function has to be smooth, and f does not have any vertical tangent lines. We would say that the derivative does not exist if any of the other following conditions hold. It's discontinuous, it has a sharp corner, or it has a vertical tangent line. So looking at the following graph, you should be able to determine the values of x where this function is not continuous. I'm sorry, you should be able to tell where it's not continuous, but you should also be able to tell where the derivative does not exist. So maybe that should be two different questions. Find and show. Where f of x is discontinuous. And then find and explain where f of x is not differentiable. So if it has a derivative, we can say it's differentiable at that value. So let me just give you a couple of minutes to try that and see if you can do that. And then we'll talk about it. So I'm just going to pause the video for a minute. So some great discussions, and you guys are understanding for the most part. So find where the function was discontinuous. So the first thing was x equals 0 is what you had said. And we can see that we have a vertical asymptote at x equals 0 as x is approaching 0 on the left-hand side. And let's show this because you guys have to be able to show why something is discontinuous. Actually, before I do that, remember there were three things that have to hold in order for a function to be continuous at a particular value. So it's continuous at some value x equals a if the function exists there, f of a exists. And the limit as x approaches a of f of x exists. So in order for a limit to exist, remember the left-hand side and the right-hand side had to give us the exact same value. And the limit as x approaches a of f of x basically is the direct substitution f of a. And so one of the conditions right here doesn't hold at x equals 0. F of 0, in our case, is undefined. So one of the conditions doesn't hold, then it's not continuous. So we could stop there. Then you guys had said, what else did you guys say? We talked about x equals -1. So notice that actually f of -1 exists. So when x is -1, if we look on the graph, remember the solid circle is where the point is. This open circle helps me where the limit is going, but it's not the same. It's not where it's defined when x is -1. And so if I look at this, so this is about -4.5. Here's my y value when x is -1. So f of -1 does exist, and it's -4.5. But the limit as x is approaching -1 on the left-hand side. So if we're looking at this coming in on the left-hand side, I don't know where my pins went, but that's okay. If we're looking at it coming in on the left-hand side, this is giving me that y value of negative 4.5. And I have a funky pen going on. So bizarre. And if I'm coming in on the right-hand side, I'm getting back, let's just make this. So this is negative 5, negative 6. How about negative 6.5? I have this funky pen going on and I don't see my pens. So I'll pause the video and change that. I don't know if you can read that. But basically these are not the same. And so the limit does not exist. So that second condition that we had up here didn't hold. And then the other place where it was discontinuous was it's undefined here when x is negative 2. I'm sorry, positive 2. When x is positive 2, I ran out of room, x equals 2. F of 2 is undefined. Okay, so it's continuous at x equals 0 because of the vertical asymptote. Also, f of 0 is undefined. Your values of x are undefined on vertical asymptotes. And then x equals negative 1 because the limit didn't exist. Left-hand side and right-hand side were not the same values. Let me clear my screen and then we'll talk about where it's discontinuous. Okay, so giving us some rooms, now we're looking at where in this graph is the function not differentiable. And so it's not differentiable when the function is discontinuous. And so we could list all those values that we had just said where it was not continuous. So that was x equals 0, that was x equals negative 1, and that was x equals 2. It also does not exist or not differentiable at sharp corners. And so you guys had found those and you said x equals 3 and x equals 5. So x equals 3 and x equals 5 were sharp corners. And then there was one other one, which had a vertical tangent line. And so in this case, x equals negative 3. So looking at a graph, you should be able, again, to be able to tell where your function is, does not have a derivative. It's not differentiable. And you should also review, looking at a graph, you should be able to find limits. And you should be able to find where the function is not continuous. You should be able to show why something is not continuous or continuous at a particular value. So let's look at an application problem, and that will kind of help us with looking at a function and looking at the rate of change and explaining what's going on when we're looking at derivatives.